For the problem statement, we are given the current as-is system for Simio drilling logistics and tasked with finding a more efficient method of material distribution to the oil drilling rigs. We are given the types of vehicles and their corresponding capacity, travel speed, and shutdown conditions based upon weather. We are also given the capital cost for the vehicles per day and the slips per month. Also, a shutdown cost occurs if a rig does not receive materials within a certain amount of time. Lastly, we are given demand schedules for the materials for each rig. Our assumptions for the as-is model are as follows. All boats are being used. Slip C is not being used. Materials for oil rigs Billy and Olympic go to Slip A, and materials for oil rigs Donnie Allen and Dan Taylor go to Slip B. Our objective is to create the best system for delivering the needed materials to the oil rigs in the most efficient manner to minimize the total cost. We began by importing images which served as the background which all other objects were placed on. We created source objects which created the model entities which represent the requested materials. The server objects represent the slips, the vehicles are represented by the cargo ships, and the sync objects represent the oil rigs. For model verification, we ran the model with breakpoints and step mode to track entity movement. In addition, Model Trace allowed us to follow vehicle movement in order to make sure that the boats were going to the right rigs. Status labels helped us to determine that the number of entities created is equal to the number of entities that were being destroyed. For the as-is results, slip cost equals $700,000 for the 2 slips being open. The vehicle cost equals $16.7 million for the 12 vehicles being used daily, and the shutdown cost equals $20.9 million. When combined, the total cost for the as-is model is equal to $38.3 million. For the 2B model, we implemented the following changes. Ships are not required to dwell until full capacity is reached. Ships are not designated to specific oil rigs. Slip C is open, allowing materials and ships to enter. Vessels have the options to pick up materials for different oil rigs in one trip. Vessels are able to travel between oil rigs, and not all vessels have to be used. Because the entities are created based on a demand schedule, there is no warm-up period in the experiment. The run length is set to 744 hours or 31 days as is specified in the problem. The experiment is run for 100 replications to reduce variability in the results. In our experiment, we took a 2-step approach in order to find the best solution. First, we varied the number of slips between 1 and 3 to perform cost-benefit analysis, having a slip open for the entire month. Then we variated the number of ships between 1 and 12 to find the optimal amount of ships that would allow us to reduce capital costs while still maintaining a low shutdown cost. From our initial experiment, we determined that 2 slips was the most cost-effective number of slips to keep open for the month. We then experimented with the different scenarios, varied the number of ships in the system, while also testing the different combinations of the vessel types, which can be seen in this small plot. As a result of our experiment, we found an optimal method for the 2B model. In our solution, the slip cost equals $700,000, resulting from 2 slips being open for the month. The total vehicle cost equals $12.4 million, and the shutdown cost equals $13.1 million. Costs add up to equal total cost of $26.2 million, which is $12.1 million less than the as-is model total cost. This is a result from the decrease in both the vehicle costs and the shutdown costs. Based upon our optimal solution, our recommendation is to have 2 out of the 3 slips open, with 4 200 type vessels running, 4 400 type vessels running, and 0 FSB type vessels running. As opposed to the as-is model, we recommend no dwell time requirement for the vessels instead of dwelling until capacity has been reached. This allows the vessels to leave more promptly after an order has been made, so that they are more likely to fulfill the order within the specified time. Another possibility is implementing new routes that would allow the boats to travel between all the rigs. This increased the amount of times that the boats spent making a delivery, and therefore it delayed the deliveries of the other materials waiting at the slips. On top of adding new routes, the materials were sent to the slip that had the smaller amount of materials already waiting. By doing this, it split up shipments that the rigs demanded and caused some of the materials to be delivered late.
Now I had the time of my life. No, I never felt like this before. Yes, I swear it's a truth, and I owe you